design of this as I will to the left. Now, if and
Hello students, welcome to my YouTube channel VRacademy. Here we are studying digital electronic circuit. So today's topic of discussion is decoder. In the last class we have completed encoder and we are knowing that what is the function of encoder. Encoder was converting a preferred symbol into binary codes. Just the reverse work is done by the decoder. Here what happens? It will convert a particular binary code into the preferred symbol or preferred number. So this is the function of decoder, and depending on its function it is getting defined. So what is the definition of decoder? It is a combinational circuit that converts any binary codes to the preferred number or symbol. So if you are coming to the prospect of defining it in a single line, you can define it as a combinational circuit that converts any kind of binary digit or binary numbers into the preferred symbol or preferred number. So coming to the decoder part, it is a device in which we have many inputs and many outputs. As I have told you, it converts binary numbers to preferred symbol. So therefore it will have many number of inputs and simultaneously it will have many number of outputs. Now depending on that, it is also named as many is to many device. I mean, we have studied about one is to many, many is to one, but this is a special kind of device which is called as many is to many. Why it is called as many is to many? Because here we are having a set of binary inputs and it is producing a number of outputs that are depending on the inputs. Okay, so in generally what happens, if we are having n number of binary inputs, the total 2 to the power n number of outputs are present. Okay, and depending on this, the nomenclature of decoder is given as n line to 2 to the power n decoder. What is n line to 2 to the power n decoder? If you are taking n value equals to 1, so it will become 1 line to 2 decoder. If you are taking n equals to 2, it becomes 2 line to 4 decoder. If you are taking n equals to 3, it becomes 3 line to 8 decoder. Now depending on its nomenclature, we are having various types of decoder. I have explained you over here. There is 2 line to 4 decoder. It is also called as sometimes as 2 is to 4 decoder, and 3 line to 8 decoder, sometimes also called as 3 is to 8 decoder, and so on. We can go for 4 line to 16, 5 line to 32. That is, we can go like that one. So we have to study these two, and depending on these two, we can have the design of all the other types of decoders. So we'll start with design of 2 line to 4 decoder or 2 is to 4 decoder. So as I am telling you, whenever we need to go for any kind of combinational circuit, the first thing is to draw the block diagram. So we'll draw the block diagram. It is 2 is to 4 decoder. I'm just writing 2 is to 4 decoder. Now definitely it will have two inputs. I'm telling those inputs as, this is your B1 and this one is B2. These are the two inputs. Okay, and since it is 2 line to 4, that means it will have 4 outputs, and I am telling those outputs as Y0, Y1, Y2 and Y3. Okay, so these are the two inputs and these are the 4 outputs to 2 line to 4 decoder. Now once we are able to design the block diagram, we'll go for the truth table. Now truth table is, we are having 2 inputs, that is B1, B2. It is better that we should be going for B0 and B1, so that we can have the better analysis, because we are using that convention only from previous examples or previous learnings. So B1 and B0, I have taken 2 inputs and I am taking 4 outputs, that is Y0, Y1, Y2 and then Y3. Okay, so these are your 4 outputs. Now if we have 2 inputs, tell me how many combinations are possible in the comment box. 4 combinations are possible, that is 0011 and 0101. Okay, you can have 00011011, that is also correct. So any of these method can be implied in order to write the combination of inputs. Now once we are done with this, if 00 is the input, if B1 is 0, B0 is 0, then in that case the output Y0 will be activated and the other values will not be activated, will be getting 0 output for that one. Now you can ask me why Y0 will be 1, because B1 equals to 0 and B0 equals to 0. This 0 and 0 combination will always be implying the value of Y0 equals to 1. The reason being the decimal value of 00 is going to be 0. So therefore, we are having activated at Y0, rest all the values are 0. Similarly, if it is 0, 1, what is the decimal value? 1. So Y1 will be activated, the other values will be equal to 0. If we are going for 1, 0, we know that all the values will be equal to 0 other than Y2. The last one will be your 1, 1. So all the values will be equal to 0 other than your Y3. Now once you have got this, you need to write the expression for each one of the output in terms of input. So Y0 will be written as B1, because the value of B1 is 0, B0 is 0, we can write it as B1 bar, B0 bar, B1 bar, B0 bar. Similarly, if I'll write about B1, it is B1 bar, B0. For Y2, it will be equal to B1, B0 bar. And for Y3, it will be B1, B0. So all the values whichever we are obtaining over here, it is depending on the value of output where it is high. I mean, if it is high at 0, 0, so we are using B1, B0 bar. If we are having Y1 value high at B1 equals to 0, B0 equals to 1, so therefore we are writing B1 bar, B0, and simultaneously we are going for the other outputs. Now once we have got the expression for the output, we know that this is in the non-reducible form. So we'll directly go for the design. So we'll take, it's a simple thing, we'll take B1 and we'll take the negation of B1. Okay. Similarly, we'll take B0 and we will take the negation of B0. We'll take the negation of B0. After taking this one, you have to just go for connections. B1 bar, B0 bar. So bar means this will be activated, I'm taking this one will be activated, I'm taking this one. Both of them are connected with a AND gate. This is the first output, that is Y0. Then second one is B1 bar, B0. So take B1 from here, B0 bar from here. Just put a dot so that it will be easier to recognize. Put a AND gate over here. This is your Y1. Next, B1 is B1, B0 bar. Take B1 from here. Okay. And B0 bar from here. Just a minute. B1 bar is there. So this was a mistake. Just change it. Okay. So here we are having B1 and B0 bar. After that, you will have the connection of an AND gate, and this is your Y2. And final one is B1, B0. Take B1 from here, take B0 from here, connect both of them by using a AND gate, and this is the value of your Y3. After having this connection, you can have the diagram, or you just block it. Okay. If you will block it, you will be able to realize what you have done. So you can clearly say two inputs are B1, B0. So B1, B0 are the inputs. 4 outputs are there. Y0, Y1, Y2, Y3 are the outputs. The only thing was to design the inside combinational circuit. This is your inside combinational circuit that will be used as 2-line to 4 decoder. So I think it is quite easy to understand. The process is very simple. 2 inputs, 4 outputs. 2 inputs, all the combinations, then 4 outputs are written. 0, 0 will imply higher values at Y0, 0, 1 will imply higher values at 1, 1, 0 will imply higher value at 2, 1, 1 will imply higher value at Y3. Write the Boolean expression for that, draw the diagram. That is your design process of 2-line to 4 decoder. Similarly, we'll be able to do design process of 3-line to 8 decoder. 3-line to 8 decoder. Now, design process of 3-line to 8 decoder is similar to what we have done in the previous case. Here, tell me what will be the input. There will be 3 inputs. Those 3 inputs will be telling that one as B0, B1 and B2. How many outputs? 8 outputs. 0, 1, 2, 3, 4, 5, 6, 7. It will start at Y0, go for Y1, Y2, Y3, Y4, Y5, Y6, Y7. And this one is 3-line to 8 decoder. 3-line to 8 decoder. Now, once you have drawn the block diagram, the next thing is to write the truth table. The truth table is very simple. We'll go for B2, B1, B0, and here we will write the 8 outputs: y0, y1, y2, y3, y4, y5, y6, y7. Okay. Now, if there are 3 inputs, how many combinations are possible, students? 8 combinations. We can write that one as 0, 0, 0, 0, and then 1, 1, 1, 1, then 0, 0, 1, 1, 0, 0, 1, 1, and finally 0, 1, 0, 1, 0, 1, 0, 1. Okay. Now, once you have written this one, you have to see that what is the activation values where it is getting activated. So, when 0, 0, 0 is the value, 1 will come at y1, the other values are going to be 0. The other values are going to be 0. If it is 0, 0, 1, all the values will be 0 other than this one. So, we will be getting this as the output. Similarly, for 0, 1, 0, you will be getting 0, 0, 1, 0, 0, 0, 0, 0. So, for 3, third line will be activated. For 4, fourth line will be activated. For 5, fifth output will be activated. For 6, sixth output will be activated. And for 7, seventh output will be activated. So diagonally you will be getting the value equals to 1. Now after doing that, the next thing is to go for the design. Now for design, you need not have to do anything. Just whatever thing you have done it over here, the same thing will be repeated. So for that, you need to write the Boolean expression first, and then you have to go for the design. So the Boolean expression is quite simple to write. It is kind of y0 will be equal to b2 bar, b1 bar, b0 bar. y1 is b2 bar, b1 bar, b1 bar, b0. y2 is b2 bar, b1, b0 bar. y3 is b2 bar, b1, b0. y4 is b2, b1 bar, b0 bar. y5 is b2, b1 bar, b0. y6 is b2 bar, b2, b1, b0 bar. y7 is b2, b1, b0. Now once you have got this, you can see that we are only using either uncomplemented binary value, uncomplemented b2 term, b1 term or b0 term, or complemented b2, b1 or b0 term. So we'll have the design process similar to that one. We'll take b2, we'll take the negation of that one, then we'll have b1, we'll take the negation of that one once again. Finally, we'll go for b0, we'll take the negation of that one. After taking all these values, b2, b1 and b0, we'll just go on drawing the diagram depending on these Boolean expression. So first one is b2 bar, so you will use this one, and you will use this one. So b2 bar, b1 bar, b0 bar. Use a AND gate. This is the first output, that is y0. Similarly, b2 bar, b1 bar, then b0. So b2 bar, b1 bar, b0. Use a AND gate. This is your second output, y1. Similarly, b2 bar, b1, b0 bar. Have that connection. Use a AND gate. This is your y2. Now in the similar process, you will go on doing it up till y2, y3, y4, y5, y6 and y7. In case of, I'm just drawing the y7 so that you can have the understanding. In case of y7, it is b2, b1 and b0. So you will take b2, b1 and b0. Connect all of them with an AND gate, and that is your output, that is y7. I think you have got this. This is all about the design of 3 line to 8 decoder. If you are blocking it, you will be able to realize that it is similar to what we have done during the block diagram. You can see that here we are having 3 lines b0, b1, b2 and 8 output lines y0 to y7. Similarly, we'll have 3 input lines and 7 output lines over here. So that completes the design process of decoders. This is what we have to study in decoders. Thank you for joining. If you have any suggestion, you can come up with that.